We've been looking at problems dealing with a few formulas. We had the simple interest formula, which was A is equal to P 1 plus RT. And we did a few problems with this one. We didn't do a whole lot of problems with it because the more interesting formulas are the compound interest formula, and the compounded continuously formula. Now we did some problems involving these formulas. So we had things like you have a certain principal, that's what P is. Let's say you put $1,000 in the bank. I'll give you an APR or a rate. I'll give you the number of times you're compounding and the amount of time you're putting it in the bank, the number of years, and you would calculate how much money you would have at the end of that amount of years. That would be for the compound interest formula. If it said in the problem compounded continuously, then you would use this formula where you don't have an n anymore. You are compounding all the time, so you don't have to worry about the n, but we do have this extra little letter, this e, which is a number. And for this one, this was the easiest one, the simple interest formula. And all you really needed was a principal, how much you put in the bank, a rate, and a time. Now I'm not going to go back over these. We did a few problems in the last video involving this stuff, so if you need a refresher, you should refer back to the last video. Just maybe the first couple of problems that introduce each one of these formulas. We're going to do something involving these formulas, but it's just a little different. So before, I'm going to write this down here. So before we knew P and we were asked to find A. You were given a principal, you were given a rate. If you were compounding continuously or compounding just a certain amount of times a year, you would be given an n, and you would be given an amount of time. But the biggest thing from these formulas was you needed to find A. That was your goal for all of the problems. This time we're going to do something different. I'm going to give you the same information. I'm going to give you an R, an N, and a T. I might not give you an N if it's compounded continuously, but I'm going to give you the A and ask for the P. Why would I want to do this? So suppose you want to have a certain amount of money in the bank after an amount of time. Say you want $50,000. Maybe you're going to buy a really expensive car, put a down payment on a house, and you know all the information from the savings account, like what the rate is, the number of years you want to save money, and you know the goal amount. But the question is, how much should I put into that account to get that goal? That's what we're going to be doing. So it's just like one extra step when we solve these. We're just going to be solving for P instead of A. All right, so before I give you the formulas for solving for P, I want to do a little review. It's just a quick review. So if we look at these formulas here, they're in terms of A. So A is equal to something. But what I just told you is we want P is equal to something because we're going to be solving for P. So to start off, if I tell you that I have an equation, something simple, x times y is z, This is solved in terms of z. So if you know x and you know y, so let's say x is 3, y is 2, you can find z from this equation. Like, all you need to do is say 3 times 2, that's 6. But what if I say x is 4, z is, let's say 2. How would you figure out what y is? Well, you can solve for y from this formula. If we're multiplying two things together, and to get y by itself, to solve for y, you divide both sides by the thing you want to get rid of. So y is going to be z divided by x, okay? That's the idea with these equations. If you look here, you have an invisible multiplication sign. When you put these things in your calculator, you have a p times this thing in parentheses. And if I want to get p by itself, I need to divide by the thing I don't want, just like I did here. I didn't want the x, I wanted the y. And so when I do that, I can get an equation for y, and all I have to do is plug in the information I need, which here I have z is 2, x is 4, so I get a half. So I'm able to figure out what y is. Now, one more thing we need to do, because if we're dividing by this long thing, it'd be easier if we were multiplying. And it'll be easier for you to put it into your calculator if you're multiplying. So the last thing I want to mention is, what if, let me erase this, I still had x times y is equal to z, but I put something on top of this x, like a squared. And I say, let's solve for y. Well, how would you do that? Well, you would do exactly what we just mentioned. You say y is equal to z divided by x squared. Now we have this fun little property with fractions. And that property says that if you have a number in the denominator raised to a power, you can actually push this thing into the numerator. And how you do that is you put a negative with that 2. So whatever this number is here it happened to be 2, but it could be a 3, it could be a 12, it could be a 300. Whatever that number is, you can push it up and make it a negative, and that way you can be multiplying. So why is this important? I'm going to erase this again. Let's look at this formula. We can look at these two formulas. Those are the ones that we're going to do problems with. We're not going to really be worried about this one at all. So let's just not even worry about this one, at least for our homework. Let's look at the compound interest formula. That's the first one. I want to solve for p. So my formula is a is equal to p times 1 plus r over n to the nt. Then to solve for p, I divide both sides by this 1 plus r over n to the nt, and that gives me p. And now I'm going to use that property I said, because this is a number. N times t is some number. And I can push it into the numerator. And I'm also going to flip this so it's easier to look at. So I'm going to say p is equal to a times 1 plus r over n to the negative nt. So this is the first formula you want to write down. Now, you won't have to memorize these formulas for the test. I'll give you the formulas, but you definitely need to know how to work them, how to use them. And now you're also going to see in the book and in the lectures, lectures, and it's a good thing to actually know where the formula is coming from, how we got it. And we just got this formula from this one right here, just solving for P. So write this down somewhere and put beside it that it's the compound interest formula. Okay? Now let's do the same thing for this formula. So I'm going to erase this part. We're going to have the same instructions. We're going to solve for P, and we have A is P-E-R-T. We're multiplying here. So then A divided by E-R-T is P. So P is A times e to the negative RT. So this will be the formula we're going to use for compounded continuously. And this gives us P in terms of A. So write this formula down and put it beside it, compound continuously. Now on a test, if I give you these formulas, I'm going to give you this one, and I'm going to give you the one that says P equals A, 1 plus R over N to the negative NT. And I'm going to give you this P is A, e to the negative RT. You'll have to know which formula to use. And how you're going to know that is, A is always the accumulated balance, what you want in the end. So if the question is asking you for the accumulated balance and they give you P, what you start off with, this is the formula you're going to use, or this one here if it's compounded monthly or daily or something. And if they give you the A and they say, this is how much money you want, what do you need to invest? You're going to use these two formulas, whichever one, depending on the information in the problem. And that's how you're going to find P. So let's look at our first problem. Okay. It says, how much must you deposit today into an account with quarterly compounding, an APR of 4.5%, in order to have $25,000 in 8 years for a down payment on a house? We need to break this problem up, see what important information we can find from it. So the first thing you'll notice is that it says quarterly compounding. Whenever you have an amount of compounding, that means you're using this A is equal to P, 1 plus R. So this formula here, let me write it down, or P is A, 1 plus R over N to the negative NT. If it says compounding continuously, if you see the word continuously, then you're using that other formula with the E. If it says simple interest, then you're going to use the very first formula, the one right here that we marked out, because we're not going to see that. Okay, so we got one of these two. Let's see what information we're given. We're told that we have an APR of 4.5%. Remember that R is 4.5% written as a decimal, which is 0.045. Remember, to convert a percentage to a decimal, you move the decimal over 2 places to the left. N is the number of times a year we compound. Notice that the problem says it's quarterly compounding, which means 4 times a year, so N is going to be 4. So that takes care of this and this. We're told that T is 8. Remember, T is always in years. So we've got this piece. Now, do we have P or do we have A in this problem? Let's look at the wording. How much must you deposit today? That means how much of the principal, like what is the principal? So that's what we're looking for. P is equal to what? In order to have, so this is the accumulated balance at the end. A is 25,000. I hope you see the difference between this problem and the problems we've done before. Before we were given P and we were asked to find A. So since we're trying to solve for P, we need to go with the equation that has P is equal to something, because that's the letter we want. Okay? So we need to plug all the information we have here into this equation. P is, A is 25,000, so let's write that down. That's our A. 1 plus our R, which is 0.045. So we've got this, divided by N, which is 4, raised to the negative 4, got the N, times T, which is 8. Okay. We've got to put this in the calculator. We need to be very careful with how we put it in the calculator, and we cannot forget this negative. Okay? If you forget the negative, you're doing this formula over here, which is not what we want. So let's put it in the calculator. Now my computer updated and made this darker, so when I switch over to the calculator, you're going to see a bright white for the calculator, and I'm sorry about that. Maybe I can figure out how to make this lighter again. Okay, so let's scroll this up so we can see it. Our formula, we're going to have 25,000 times 1 plus, remember I said the more parentheses the better, because it's telling your calculator how to simplify this long equation. 0.045 divided by 4. Okay. Close both parentheses, the one here that I'm putting this fraction in, and then I'm adding 1 to it, and then I'm closing this parentheses. Then remember you've got to raise it, and we must have a parentheses here. Okay, this is not optional, because if you don't put the parentheses, it's only going to raise it to the negative 4. So negative 4 times 8. Okay? You can see this is 25,000, 1 plus 0.045 divided by 4, raised to the negative 4 times 8. And then we hit enter. We get 17,477. So let's write that. 17,477. Let's round to the nearest cent, which means round to the hundredth. 0.00. So we need to put $17,000, almost $17,500, into the bank account for 8 years in order to get $25,000. So this is what you got to put in to make sure you get that $25,000 after the 8 years. Now that's a lot of money compared to the $25,000, and the reason it's so high is because the APR is low and the number of times we're compounding is low as well. All right, let's try another one. By the way, before I move on, I think it might be helpful if I just write this down. If you have a TI-30X, or in fact I think any calculator, but definitely this one, you can write this exactly like this and get the right answer in the calculator. Because some calculators will show it to you just like this, you'll be able to write it just like this, but other ones look a little more complicated. Like you have to write it with this division sign, this caret key. So if you put it just like this in the calculator, you'll get the right answer. Okay? Making sure that you have this in parentheses and this in parentheses, and you can put an extra parentheses in here if you like. I don't think it's necessary, but you can. Let's look at the next problem. How much must you deposit today in an account with daily compounding and an APR of 4% in order to have $30,000 in 10 years for a down payment on a house. Okay, let's write the important information. We're looking for how much we must deposit today. So today means what is your P? That is what we're looking for. So let me cross that out. We have daily compounding. Remember that daily compounding goes with the 1 plus R over N formula. And daily is the N. So that's telling us that N is 365 because we're getting interest every day. So we can get rid of this piece. APR of 4%, that tells us our rate is 0.04. Got that. In order to have 30,000, so that's what we want in the N, 30,000. And our time is 10. For a down payment on a house. All right, let's write our formula that we need. Since we need to solve for P, we need to use this formula here. Okay, let's put everything we have in the formula. So 30,000 for the A, 1 plus 0.04 divided by 365 raised to the negative 365 times 10. I'm going to put that in the calculator. So 30,000 times 1 plus 0.04 divided by 365 raised to the negative 365 times 10. Let's just double check we have all the pieces. 30,000, 0.04, 365, we got the 1, and the negative 365 at 10. 2110 0.04, rounding to the nearest cent or the hundredth because it's money, and that is our answer. So what does that tell us? We need to put $20,000 in the bank to ensure that we have $30,000 in 10 years with this kind of compounding, daily compounding, and this interest rate. Now, if we change the type of compounding or the interest rate, this amount would change as well. Okay. This problem is going to be a lot of fun because we're going to learn how to choose between two options. So two options when it deals with which is the best for us for the retirement fund. So it says, suppose you want to accumulate $120,000 for your retirement in 30 years. You have two choices. There's one plan called Plan A, where you can put a single deposit into an account with annual compounding and an APR of 5%. Plan B is a single deposit into an account with continuous compounding and an APR of 4.8%. How much do you need to deposit in each account in order to reach the goal? So this is like there being two different banks, and you're trying to figure out which bank I should put my money in to reach my goal of $120,000. Bank with Plan A or another bank with Plan B. Now, what do you think you would want to happen if you reached the $120,000 from both accounts? What do you think would be the better bank? How would you know which bank is better for you? Which bank you should choose? Well, the bank that's better is the one with the smallest amount that you have to put in. If you want to put in let's say, for example, Plan A, you have to put in $50,000, and in 30 years you'll get your $120,000. But in Plan B, let's say you have to put $20,000 in, and then you get $120,000 at the end of your 30 years. Obviously, you would want to go with Plan B because it's like cheaper in a way. It's less money you have to put in because you're getting more money out. You're only putting $20,000 in, and you're reaching your goal. While with the other bank, I think I said $50,000, you'd have to put more money in to reach your goal. Okay, so let's see the differences between these two banks. Here I'm going to do in red Plan A. So Plan A is a single deposit with APR, so R is 0.05. Let's cross out things that we write down. Plan B, let's do Plan B in green. It's a single deposit with continuous compounding, APR 4.8%. So let's write 0.048 for our APR. In both of these accounts, we want to accumulate $120,000. So that's what we want A to be, $120,000. Okay, get rid of that. And it's going to be the same amount of time. T is going to be 30 years for both of these banks. Okay? Now, we need to figure out if there's anything else we need. Let's read carefully. Plan A has annual compounding. Okay? Annual compounding, that tells us the N. N here is going to be 1. And because it's an annual compounding, we're using the formula. P is A, 1 plus R over N to the negative NT. Remember, we're solving for P. We're trying to figure out how much we should put in to make our goal of $120,000. So I think Plan A is complete. Now let's read Plan B pretty carefully here. It says continuous compounding. Okay, remember that continuous compounding has a special formula involving an E. So the difference, if we're solving for P, is that we put A e to the negative RT. You might want to review your notes. We talked about this in the beginning of the video. I think we have all the pieces we need to figure out the P in both plans. Let's do Plan A first. So P is 120,000. 1 plus 0.05 divided by 1 raised to the negative 1 times T, which is 30. Okay, let's put that in the calculator. So 120,000 times 1 plus, now anything divided by 1 is itself, so all I really need to write is 0.05. I don't have to put 0.05 divided by 1. Raised, and then negative 1 times 30 is just negative 30. Oops, let me do that again. 120,000, 1 plus 0.05 raised to the negative 30. Enter. 27,765 0.29. Okay, so for Plan A, to reach our goal, we have to put $27,765. So $27,765, and a little bit extra. Let me circle that so it's easy to reference. Let's do Plan B. So P is going to be the 120,000, E to the negative, well, our rate is 0.048 times T, which is 30, Remember, all of this needs to go into parentheses in the calculator. So we're going to do 120,000 e to the negative 0.048 times 30. Now let's just be very careful. Make sure we put it in just like we see it here. 120,000 negative 0.048 times 30. Hit enter. 28,431.33. Okay, now let's compare the two values. The first value was 27,000 and something. The second one is 28,000 and something. Which one do you think is the better plan? Which plan would you go with? And that is going to be Plan B. Because in Plan B, you have to put in less money. Oh, wait a second. Is that right? No. Plan A. Plan A is better. So maybe I got confused for a second. Plan A is better. Why is it better? Because you have to put in less money to reach your goal. Putting in $27,000, just think about it. Would you rather give somebody $27,000 and something and then say in 30 years I'm going to take that money and make it $120,000, or would you rather give somebody $28,000 and something and then they make it $120,000 later? Obviously you want to give less money. So less money is better.